Hello and a very good day. So today our group will be presenting our proposal for a revised workflow of manufacturing process involving function check and appearance checks. So the main objective of our project is none other than to reduce or eliminate the needs for operators in this production line. But before we make any changes, it's important that we understand the initial workflow of this production line. Next slide, please. So based on this workflow, we can see that there are some work elements that require human intervention. For example, placing product on jig workbase, removing product from the workbase, and passing the product to the next operator. In addition, the appearance check function using magnifying glass is also manual. So our aim is to eliminate any needs for operators at these workstations. However, it's important that we understand that in order for us to design a new workflow, we must first decide on the product type. So we have chosen the product type in advance and also the process parameters so that appropriate machines for function and appearance checks can be chosen and tailored to this product. So as a result, the product that we have chosen for our project is actually a toy block or a Lego piece. So the function check in this proposal determines if the Lego piece dimension or in specific height is within the tolerance range, whereas the appearance check identifies color faults, for example, color fading or paint wear on the Lego piece. So how exactly can we actually eliminate human intervention is we need to change the processing path and as well introduce new instruments that can operate the machines in a way that eliminates the need for physical handling. However, the concept is not as straightforward as it sounds. For the process to run properly, the time as well as the position of the instruments and product during the process must be considered. For example, the conveyor belt. Next slide, please. So the conveyor belt is only used to transfer items in the first process before they are picked up and placed on the function check. So this is for the initial workflow, the conveyor belt is only used to transfer items to the transfer items before they are picked up and placed on the inspection jig. So this process is manual. That's why we believe that if we build a conveyor belt which can connect these two different machines, then the manual displacement of products will not be necessary. Next slide. For function check, we propose a function check setup with an inbuilt IR proximity sensor so that the IR proximity sensor can alert the machine once the product is at its workbase. Therefore, it will operate once it detects an item and the conveyor belt will stop operating. So for simulation purpose in Factory IO, however, we have designed a setup that mimics the function to check for tolerances like an inspection jig, in particular the function to check for product dimension, height, or in this case, for this simulation, we have used capacitive sensor. However, for actual application might be different. But it stands to reason that this setup is only made possible because we have chosen a Lego piece as our product for this particular proposal. I'll pass on the presentation to the next presenter, Mashta.
Okay, next for the appearance checks, we use an advanced vision camera sensor with advanced algorithm to check whether there is a defect at the product. So the sensor will help us to sort out whether the Lego is defected or not. Instead of using the manual magnifying glass, which makes the inspection process duration longer than using vision sensor. And then next slide. And then if the sensor detect a defect product, and then the pusher will be activated and it will push the defected product out of the main conveyor belt to the malfunction product conveyor. So as we can see here, if the product detected is defect, like for defect expression, if the sensor detect a defected product, then the pusher will be activated and push the defected product out of the main conveyor belt. So as we can see here, for example, at the inspection jig here, at the functional check, packing process. If the in this simulation we use a product with a pallet as a defected product. So the after the sensor detect it, it will push the product out of the conveyor belt. Okay, next. Then at the entrance of the another conveyor belt, there is a sensor which will detect how many product is being pushed at the secondary conveyor belt. So the sensor will count, and the counter will be displayed at this display. And as you can see here, there is also a reset button, which if another operator take out the defected product from the NG box, then they can reset the numbers of defected or the good product counted. Okay, next. So this is our new workflow. It starts with the product is placed on motor conveyor automatically, and then the product will move into the inspection jig machine by motor conveyor. After that, the product will pass through the diffuse sensor at jig workbase. Then if the sensor detect a product, it will move to it. The motor conveyor will stop, but if there is no product detected, it will wait until there is a product detected. So after the motor conveyor stop, the inspection jig will be operated automatically and for functional check. So after that, if the product is functioning, then the conveyor motor will start again, and the product will move to the appearance check and packing machine. But if there is a malfunctioning at the product, then the piston or the pusher will push the product into another conveyor belt and then into the NG box. So after that, the product will pass through the optical sensor or the vision camera to undergo appearance checks. So if there is a defect detected at the product, then the pusher will be activated, and the product will be pushed out of the main motor conveyor and then into the NG box. But if there is no defect detected, then the product will move to the packing box. Okay, next. So this is the simulation that we use by using factory IO simulation. So for this simulation, we would like to highlight that it does not represent our actual operation due to the limitation of the software. And the reason why this simulation is being done is just to give the idea how the product is being transferred from one machine to another machine, and how the product is being sorted between the good product and the defective product. So as you can see here, the defective product, we assume that the blue product color is the defected product and the green is the good product. And there's also counter to count how many good product and defected product. So that's all from me. Next, I will pass to the next presenter.
Okay, thank you, Mashita. So this is our ladder diagram simulation. So basically, this is the actual simulation that we follow based on the new workflow that has been proposed by our members. So as you can see here, there are different types of components that we use here. For example, time off delay, time on delay, and also contact NONC, and also all kind of the operation based on the workflow. So for example, we have the diffuser sensor. So the diffuser sensor is where we detect the item on the conveyor belt, whether they have reached the workspace of the jig inspection. And then we also have the pickup operation. So basically where the items will be picked up from the conveyor into the jig space workspace. Next. So here we have, for example, we have the counters for the dimension error. So basically, this part is where we detect to detect the dimension error received from the function check. So by after they detect the defects, they will count out of the phase of the dimension error. So and then we have the after push. This is the delay for the solenoid at the function check. Okay, next. So this is also another example of counters for the successful function checks. Next. And here is the example the diagram for our appearance check when using the visual cameras. So we also have the counters for both the success item and also the defect items. And we also have the delay timers for the solenoid. Next. So next, we will see a simulation in Codesys using a visualization based on the ladder diagram that has been shown. Okay, so here this is the simulation based on the ladder diagram simulation. So here we have the variables, for example, the DP sensor, jig sensor, and also the variables for the inspection jig, the appearance check. We also have the push buttons for start button and also the emergency stop. And here is the counters. So basically this is where we can find out how many items has been successful or failed. So this is actually the preset value. So this is depending on the factory itself, like how many items that we want per day. So for example, here we have set it to 10 items per day. So first we start off by start the pushing button, which will which we activate the conveyor belt after pressing the start button. So after the conveyor belt moves, then the item will be detected by the diffuser sensor, which we activated the pickup processes to transfer into the jig sensor, which then activate the jig workspace and proceed with the inspection jig process. And this process will take about 10 seconds. After 10 seconds, the inspection jig the function check will determine whether the item is defect or pass. So for example, in this case, is it pass? So if it pass, we will put back the item into the conveyor belt. So the conveyor belt will resume into moving again, proceed into the next station, which is the appearance check. So appearance check will be detected by the visual cameras. So after the visual camera is detected, the appearance check process will be activated, which then determines whether the appearances or the visuals of the item is correct or not. So for example, if the item is incorrect, the solenoid will activate to push the item into the NG box. And as you can see here, the count out will activated based on what are the determined by the processes results. So as you say, the inspection jig was successful, so it will increment from 1 to 2. And for example, in the appearance check was incorrect color, so from 3 it will increment to 1, which is 4. So I will pass next to Hasif to talk about the timing diagram of our ladder diagram.
After visualizing and simulating the production, we managed to produce a timing chart for the production. Firstly, there will be on delay and off delay timers for 1 second at both starting and stopping process to ensure that it is safe to start and stop the production. The product will then arrive at the first checkpoint, which is at the inspection jig from the starting point after 7 seconds, since the conveyor belt will be moving at 0.3 meter per second and the distance will be approximately 2 meter apart. So if any defect is detected at the jig, it will give feedback to the pusher and it will push the product into the NG box while the conveyor is running. So the inspection process will run for 11 seconds, including the 1 second delay. And after the sensor detect the product has arrived, and 10 seconds for the actual inspection. So after another 7 seconds, the product will then arrive at vision camera for from the inspection jig, and the vision camera will detect any defect instantly and give feedback to the pusher if any defect is detected, and the pusher will run for 3 seconds while the conveyor is running. After the stopping process is initiated, all the process will stop and the conveyor belt will be in lockout mode for 1 second for safety purposes. So the total production time for one good product will be 25 seconds, 11 seconds for the inspection process, and 14 seconds for the inter-arrival time of the product, excluding the start and stop time. The 3 second process time for the pusher when a defect is detected is excluded, since the process runs regardless of the movement of the conveyor belt. I'll pass to Irfan for the next part.
To illustrate the process in a simplified circuit, we have used Proteus and Arduino software to fabricate and simulate a schematic imitation of a proposed process circuit using Arduino Uno boards, or in this case, we call it microcontrollers. So this figure shows a schematic diagram made using Proteus. So in this schematic diagram, however, instead of using diffuser sensor or photoelectric sensor, we have used IR proximity sensor. This sensor is used for product detection and counter. So here we can notice that there are three different Arduino boards. The first Arduino board is for function check. Second one is for vision sensor, and the last one is for the product counter. So as we can see here also, the function check Arduino board is connected to the motor. So it means that the function check Arduino board controls the motor. So if the proximity sensor here on the left side, we can see IR for function check, detects an object, it will alert the Arduino board. Thus, the Arduino board will stop the motor and the machine will start to operate. Now I'll show you a short simulation of our schematic diagram. So as we can see here, these are the full layout of our circuits. And then for each, we can see that there are logic states here, logic state connected to the IR function check, logic state connected to the function check Arduino board, vision sensor, and also for the product counter. So this logic state will, the logic state connected to the function check will tell the function check whether or not the products that it detects has defects. The same goes for the vision sensors. Now I'll show you a short simulation of our. So when the simulation is run, we can see that the status of the machine is displayed on the virtual terminal. So at first, it shows that the machine is not operating. This is because the function check Arduino board does not detect any object. However, when it detects an object, the status will display that the machine is operating. Thus, the motor will stop functioning. You can see the motor has stopped functioning. Okay. For this logistic, like I said earlier, it tells the Arduino board whether or not the product that it inspects has defects. So if this logistic, I toggle it to 1, then the function check Arduino board will tell the pusher that the product that it inspects has defect. Therefore, pusher will be operated. And the status will display defect detected, pusher is operating. And also once it has been pushed, the counter will show that the product defects, this virtual terminal will show the number of defects detected. So like what I said earlier, if the inspection jig detects a defect, then the solenoid will start functioning, and then it will push it to another conveyor belt. There, located at the conveyor belt, new conveyor belt, will be photoelectric sensors, which acts as a counter. So the photoelectric sensor will display that defects detected at inspection check is 1 for now. Okay. So the same goes for vision sensor. So if the vision sensor, the logic stick here connected to the A1 pin of the vision sensor Arduino board has a high value, high state, therefore the vision sensor will alert the solenoid to start functioning. You can see here vision camera is operating. On the right hand side it says defect detected, pusher is operating. Then the solenoid will start functioning for 3 seconds and it stops. You can also see that there's a counter for appearance check as well. Defect detected at the appearance check is 1. So I think that's all from me. I think our group have managed to accomplish the objective of our project, which is to reduce the number of operators in our production line. Kita stop je. I think that's all for the Proteus simulation. I think that our group has managed to achieve our objective, which is to reduce the number of operators in our production line. And that's all from us. Thank you.